In this video, we're going to start talking about parallel lines and how they can be used to solve angles. So let's first talk about the parallel line theorem, where, as you can see, there are three types of parallel line theorems. But in general, the parallel line theorem applies to two parallel lines, both intersected by another line. Also, we denote parallel lines by using these angled symbols to show that they point in the same direction. So, for example, in the parallel line theorem Z pattern, we have these two arrows to show that these two lines are parallel. Also, if in a diagram we have two sets of parallel lines, you might see these two symbols used for the two parallel lines that come first, and a second set of parallel lines might be denoted by using a double arrow on each of those lines. So let's get started by looking at the parallel line theorem. So we have the parallel line theorem is Z pattern first. So we try to look for a Z in our parallel line. So we see that if we come across along this line, go down our intersecting line, and then continue along this parallel line, we have a Z pattern right in here. Therefore, angle Z is equal to angle B. Also, we see that there is another parallel line theorem Z pattern. If we have a backward Z, so we come across this line, go down our intersecting line, and then continue this way. Right in here, it's backwards and it's a little stretched, so we can say that Y is also equal to A because of the parallel line theorem Z pattern. Now let's look at the F pattern. So let's look for F's. We see that there's an F right in here. If we come across this line, go down our intersecting line, and then have this little stick out here. So angle Y is equal to angle C because of this pattern. We also have a backwards F right in here, where we have our two parallel lines coming in here to these vertexes, and then a drop straight down for our post, if you will. So we could say that Z is equal to D. And then finally we have upside down F's, and we have two of them. So one is right in here. So we come across this line and shoot straight up, and then have this stick out here. So we could say that X is equal to B. And finally we have an upside down and backwards F right in here, where if we come across this way and shoot straight up, along with this line, we could say that W is equal to A. And those are all because of the parallel line theorem F pattern. Now let's look at the C pattern. We want to look for C. So we see that there's a C right in here. If we come across, shoot down, and then shoot out again. So right in here, we have a parallel line theorem C pattern, which means that B plus Y is equal to 180 degrees. Similarly, we have another C pattern that's backwards. So we could say that angle C and angle A, if we added them up, Z and A, that'll equal also 180 degrees because of the C pattern, where this C is backwards. Now let's look at some questions. Question 1 says, determine the missing angle. So for part A, we can right away see that there's a C pattern right in here, with angle A and this angle 59 degrees. So we know that A plus 59 degrees is equal to 180 degrees because of PLT-C. So if we subtract 59 from both sides, we find that A would be equal to 180 minus 59. So A is equal to 121 degrees. We can also use the opposite angle theorem here to find what B is. So B is also equal to 121 degrees because of the opposite angle theorem. Note that we could have found angle B using a variety of other ways, and if you used a different way, by all means, there's nothing wrong with that. For example, we could have used the supplementary angle theorem to find this angle right in here. Maybe I'll color it green to show. And then we could have used the parallel theorem F pattern to show that B is equal to this angle right in here. So there is always alternative ways to find these angles. This is just one possible solution. So let's move on to B now. So let's start here. We see that we have a parallel line theorem Z pattern right in here. So we know that angle B is equal to 82 degrees because of parallel line theorem Z pattern. I'm going to also, maybe I'll do it in green, put a little symbol in here, F. So that'll be our F angle right in there. And we know that F would also be equal to 82 degrees because of OAT, the opposite angle theorem. And inside this little triangle here at the bottom, we can apply the sum of the angles inside a triangle theorem. So we know that A plus 67 plus 82 degrees will equal 180 degrees because of SATT. And if we rearrange this, we would find that A is equal to 180 minus 67 minus 82, because we subtracted these two numbers from both sides of the equal sign. Therefore, A would be equal to 31 degrees. We can now find angle D, where D plus 67 degrees will equal 180 degrees because of the supplementary angle theorem, which is right in here. So D plus 67 will equal our 180 degree from this line all the way to this line. And if we rearrange this, we could solve for D. So D is equal to 180 minus 67 degrees. So therefore, D would be equal to 113 degrees. We can now use the sum of the interior angles of a triangle theorem again with angle A, 82, and C. So C plus 82 degrees plus angle A, which we found to be 31 degrees, is equal to 180 degrees because of SATT. Now let's subtract 82 and 31 from both sides. So C would be equal to 180 degrees minus 82 degrees minus 31 degrees. Therefore, C would be equal to 67 degrees. And finally, we can find E by seeing that E is equal to D, which is 113 degrees, because of the parallel line theorem F pattern. So right in here, we have a backwards, upside down F. All right. Now I'm going to circle this or divide it so we don't get confused between it and question D when we do it. Let's now move on to C though. So in C, we see that we have parallel line theorem F pattern right in here. So we can say that B is equal to 64 degrees because of PLT-F. We can also see that D is equal to 64 degrees because of either OAT, or we could even write because of PLT-Z, where there's a Z pattern right in here. So there with this B. And maybe I'll switch the color when we move on. So we know that because this triangle right in here is a isosceles triangle, meaning these two sides are equal, we can apply the isosceles triangle theorem, ITT. So therefore we know that C is equal to D, which is also 64 degrees, because of the isosceles triangle theorem. And then we can find A using the sum of the interior angles of a triangle theorem. So A plus C plus D, which are both 64, so plus 64 plus 64, is equal to 180 degrees. And that's all because of the sum of the angles of a triangle theorem. So A would be equal to, if we subtract 64 from both sides of the equal sign, it'll be equal to this. Therefore, A is equal to 52 degrees. And finally, we want to find E. And we could say that E is equal to A plus B, because we have parallel line theorem Z pattern, and it's a little stretch, but there's a Z there. So E would be equal to 52 plus 64 degrees. Therefore, E is equal to 116 degrees. And finally, we have question D. So we could say that A plus 77 degrees plus 26 degrees will equal 180 degrees because of the sum of the angles of a triangle theorem. And we can rearrange this. So A would be equal to 180 degrees minus 77 degrees minus 26 degrees. And all we did to do this was we subtracted 77 and 26 from both sides of the equal sign. And if we calculate this, we find that A is equal to 77 degrees. We now want to find angle C, and we can use the opposite angle theorem with A. So C would also be equal to 77 degrees because of opposite angle theorem. Then we could also say that angle B is equal to 26 degrees because of PLT-Z. So we have a Z pattern right in here. So it's like kind of like a sideways Z. And finally, we have PLT-F pattern with D and this 77 right here. Because these two lines stick out, and we have a sideways downward facing F. So D would also be equal to 77 degrees because of PLT-F. So let's continue with question 1 here, and these are the last 4 for the video. So let's start with E. We want to determine these missing angles, and we're given this angle right in here. So right away we see that there is a PLT-Z pattern right in there. So D is equal to 41 degrees because of PLT, the parallel line theorem, Z pattern. We can also see that angle B and angle D can be added together. So B plus D, which we know is 41 degrees, is equal to 180 degrees because of PLT, the parallel line theorem, C pattern. And let's subtract 41 from both sides, so we get 180 minus 41. Therefore, angle B is equal to 139 degrees. We can also find angle C using the parallel line theorem F pattern right in here. So C is equal to 41 degrees because of the parallel line theorem F pattern. And finally, we can say that angle A is equal to angle C, which is 41 degrees, because of the isosceles triangle theorem, ITT. Question F. So we see that B is equal to 53 degrees because of the parallel line theorem Z pattern. So we have a Z right in here. That's backwards. And we also have another Z, but this one is forward between here and here. So we can say that angle A is equal to 78 degrees because of PLT-Z as well. And now we want to find C, but to find C, we maybe need to first find one of these two angles in here. So we can use the sum of the interior angles of a triangle theorem, either in this triangle or in this triangle. Let's label this maybe W. So if we added W plus B, which is 53 degrees, plus 78 degrees, we know that we would equal 180 degrees because of the sum of the angles in the triangle theorem. Now let's isolate for W by subtracting 53 and 78 from both sides of the equal sign. Therefore, W is equal to 49 degrees. And we can find angle C because C plus W, or 49 degrees, is equal to 180 degrees because of the supplementary angle theorem, SAT, right in here. So let's subtract 49 from both sides. Therefore, C is equal to 131 degrees. G. So in G, we have a PLT-Z pattern right in here. So we know right away that B is equal to 70 degrees because of the parallel line theorem Z pattern. And we can also find A because A plus 60 plus B, which is 70, will equal 180 degrees because of the supplementary angle theorem. All of these angles will add to 180, so SAT. So let's bring the 60 and 70 to the other side by subtracting it from both sides. So A would be equal to 180 degrees minus 60 degrees minus 70 degrees. Therefore, A is equal to 50 degrees. So in H, we have a parallel line theorem F pattern right in here. So we right away know that A is equal to 60 degrees because of PLT-F. We can find C by using the sum of the angles in a triangle theorem. So we could say that C plus 40 plus A, which is 60, is equal to 180 degrees because of the sum of the angles in a triangle theorem. Therefore, C would be equal to 180 minus 40 degrees minus 60 degrees. So we just subtracted 40 and 60 from both sides of the equal sign. Therefore, C is equal to 80 degrees. And lastly, we want to find B. So for angle B, we see that we have a Z pattern right in here. Maybe we'll do it in red. So we have a Z pattern right in there. That's sort of sideways. So B would be equal to 40 degrees because of the parallel line theorem Z pattern. And that's it for this video.